So welcome to LNP Renewable System Director. Today we are going to discuss about how to do UPS inverter wiring, connections to your homes and the offices with the existing single phase connections. So what we are going to discuss today, how we need to make electrical connections for the homes and the offices. If you are planning to install a UPS or a battery support to your home, how you can do it, and how the power flow will be available when the main power supply is cut off, how it gets restored when the power comes back, and most importantly, there is one more advanced method which is available. Normally most of the people won't do it, but if you want to do the same thing to your home, you can follow this method. That is, you can connect the UPS or the inverter along with the home electrical lines using a manual changeover switch or auto changeover switch. Come, let's get into the topic. This is a simple wiring diagram for the home and office connections. So this is a normal inverter and this is the battery. This is the main line. So by utilizing the power from the main line, the battery is getting charged, and this is the electrical output, the line and the neutral that you're taking out. And you're giving a line to the normal existing loads and the neutral to the loads. If any interruption occurs, automatically since it is the actual line is passing through the inverter, even though the line is not available, immediately the backup of the batteries will come into the operation, and the exact requirement output will be provided, and the loads will run continuously. And if you are making any advanced connections for your existing system, maybe you might have a in the distribution box you might have an MCB, and in the supply load side you might have the MCBs, and most importantly, whenever you do any sort of wirings, always try to give proper earth links, and also from the 3-pin socket also you can charge your batteries through your inverters. And this is the line and neutral distribution, how it is getting wired. See here, this is the main supply. So through the main DB, this will be the main MCB. This is of there won't be any supply to even to the loads and for the charging of the batteries also. This is the main, and these are the distribution MCBs. It might be going to the other loads, other rooms. So let us try to consider only the 2 rooms. It has a light, it has 2 lights and a fan. And even it has a 2-pin power sockets also. So this is how you need to wire your connections properly. Now let us consider the scenario. We have 2 rooms, we have 2 lights and 1 fan, and in both the rooms, if any interruption from this main line happens, what will happen? Immediately the battery power which stores charge energy will provide the energy back, so that the DC will be converted to AC by this inverter, and this blue line indicates the line of control. It means the line power will try to go through this path to the 2 respective rooms. Now when the actual power is on, then this is how the power line will happen. So it will come to the inverter. From the inverter it will pass through the rest of the rooms. The blue lines shows the power flow path. Now let us consider another scenario. Most importantly, whenever you do any sort of wirings to the home supply, always use the proper MCBs for the protection. There should be an MCB for the main line. It might be a single phase or 3 phase, it's up to your requirement, but wherever you go, please provide a separate MCB in the distribution box for the main power, and for the other loads, use the small MCBs based on the load distribution. And now when you want to make this is the last, all the models that we saw is the normal inverter wiring, but when you want to do inverter wiring along with the manual changeover switch, then you can follow this wiring. See here, this is the main supply. So from the main supply we are connecting from the line and the neutral, we are taking the 2-pole single phase manual changeover switch. It has 3 positions. Center will be the off, upward will be the one position, and downward will be the one position. Simple. When it is upward, main line is getting connected. Okay. When it is downward, what is happening? See here. From the inverter, okay, from the inverter the supply is going to the MCB, and from there the output is coming. We are supplying to the 2 rooms, and even for the individual rooms also, lower wise you can have a circuit breakers. So that why we are going for the separate circuit breakers means, because anyway in order to isolate from the main power we need a MCB, okay, and apart from it individually, if any tripping happening, so you are doing any sort of maintenance, so if you go for MCBs like this now, it might be very much useful. Okay, see here, this is a 2-pole single phase manual changeover switch. By changing the position of this MCB, we can able to change the positions and get the required outputs. See, if you need a main power supply, you can keep in this position, and if you change to UPS supply, it will come into this position. Okay, so as we told earlier, even in certain places, instead of going for normal changeovers, okay, you can go with the transfer switches also. And most importantly, whenever you make any sort of connection, even for the UPS supply also, you can make a isolation protections for the particular rooms. See here, this is a inverter, this is the actual photo of the inverter, this is the battery, and we have 2 rooms, and in order to protect those 2 rooms we have a separate circuit breakers. Okay, and apart from it, even for the UPS supply, see here, this is the position. If it is upward position, it will be in the main line supply, and if it is at the downward position, it means it will be in the UPS supply. So from the battery, 12 volt, the inverter will convert the 12 volt to 230, and it, with the help of this 2-pole manual changeover switch, it is getting distributed to this DP MCB. From the DP MCB via RCB, it will get distributed to the other circuit breakers. And also, if you want to make an automatic changeover switch also, you can make the connection like this. This is one of the sample automatic changeover switch. There are so many varieties available. This is one of the model which is also available in the market, and this is another model. So if you connect through these changeover switches with the proper timing, and if you make it on, so that when any interruption occurs, automatically it will switch over, no need to change anything. Okay, see here, this is the 12 volt supply, and this is the main line. So we are connecting the main line to the inverter. It is charging it, and even we are taking one more line from the main line. We are giving it to the changeover, automatic changeover switch, and even the UPS input also we are providing to the changeover switch, and we are taking 2 outputs. Both outputs will be given to the main lines. Okay, as we told earlier, always provide proper earthing connections, and also neutral bus bar terminals also please provide it properly. Okay, and this is a connection that we had shown for a single phase 230 volt wiring. Okay, thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We have provided the contact details in it. We are providing solar on-grid, off-grid, hybrid design, installation, testing, and commissioning supports also. If you want to design a solar DC systems also, you can contact us. We have provided the contact details here, and we are also providing home automation, building automation, building management system. If you had a plan to work in the abroad GCC countries, if you want a training, you can contact us. We have provided the contact details here. And in order to know regarding the electric vehicle basics also, you can contact us. We have provided the contact details here. Thank you.